Yes, people in this community know Jan as a decision table professor. And I would say that in the last several years, something new started to come from KU Leuven. They're running their own international decision management webinar, and I believe Jan managed to surround himself by young researchers who really contribute well to decision management movement in different disciplines, and probably today with his young colleague he will present automated decision making from A to Z. And at the end of the day, we will hear another group of young researchers that will contribute to constraint-based DMN. And congratulations, Jan, on all these achievements. And please take over.
Thank you, Jacob. I hope the settings are okay. I'm indeed from the University of Leuven in Belgium. Actually, the other group is also from the same university, but it's not one of my offsprings. We just happen to do the same thing, and we are now working together. All right, so the topic is, just to give it the name, automated decision making from A to Z, meaning how can we go from the very early beginning of what we do in decision making to the final execution or the final application. And this is worked together with indeed the new PhD student, Veda. You see his picture here. He will be on the participants list, and we have a good agreement. I'll do the presentation, and if you have any difficult questions, you can ask him. All right. So what is the setting here? The setting is that if you look at DMN and decision modeling and decision making, we have been doing a lot of things. With we, I mean the DMN community. We have been doing modeling, and we know all about validation, execution, explanation, application. However, there is one question which is very rarely asked or very rarely treated. Where does the decision model come from? We easily assume that we start from a set of rules, or we start from some tables which come from magic, or we have a DRD which we have constructed, but where does it really come from? How do we get to the model? That's not the same as modeling. That's really the acquisition part. And of course, there are a number of ways to get there. For instance, you could build a decision model in a manual way. That's the most common method. We've been doing it for so many years. You have a few methodology books. You have the books by Alan. You have books by Jacob, by James, by Bruce. You can do it with or without processes. More and more, we do this in an integrated way, but it's a manual effort. Manual means expensive. Or you can do it in a more automatic way. You can try to derive a model from code, as Larry was talking about yesterday, or from event logs and process models, from data, actually, from historical data sets. You can build your decision tree and then table. I should use the word table at least once in this presentation. So you can build your decision model from case files, from data. Actually, then you're doing analytics. Or, and that's what I would like to talk about today, you can build it from text, which is an old dream, of course. So we will try to do that. So when we model decisions, there are a number of ways. For instance, you can extract your model from a process. There's a lot of literature about this, how to extract a decision model from a process model, which is ready. So simplifying the process model means extracting the gateways, extracting some things, and so on, and so on. That's one way to do it. Of course, the assumption is that you have a complete process model to extract your decision model. Or you can extract rules and tables from code. Program understanding, program re-engineering, we have seen this before. Trying to get rules from code, or decisions from code, or decision tables, or decision models from code. But of course, you need to have the code. Or you can try to extract your model from data and cases and logs and events, if you have them. For instance, what machine learning is doing in a lot of cases is you have historical data and you try to extract decision trees or networks or models or decision tables. We've been doing it earlier using Ripper Brian to extract the rules from a neural network by looking at the configuration of the neural networks and then build some kind of more explainable decision table to replace the neural network. That's an option. Or you can extract it from case data, not to a decision table, but to a full requirements diagram. Would be possible if you have the case data. Or at the site of the events, there is the area of process mining, where you extract process models from event logs. Well, if these event logs are enriched with other case data, then you can extract the process model plus the decision model, which is called decision mining. You extract decisions in specific points in the process model. Or if you do it in a more integrated way, you extract both the process model and the decision model at the same time, so one doesn't depend on the other. We call it integrated mining. Then you can extract decision models from data and event logs. That's all not the subject of today. The subject of today is, could we do this from text? We see it in other worlds. For instance, process models, to some extent, can be generated from text. There are some papers, there are some works where we build a process model based on a description, a text of the process. And of course, we want to extract a decision model, not just a set of rules, not just a table, but what we try to do, what I present here is, could we derive a decision model consisting of the requirements diagram and the decision logic, and maybe some other components, but let's focus on these first. It's already difficult enough. And let's first focus on the DRDs, because the decision logic is logical rules, and you know that a lot of legal texts contain very complex sentences, so let's start with the easy part and then do the more difficult part. But that's the subject of today, which is called text to DEC. Text to decisions. We start from a text. Why do we start from a text? Well, because there are so many texts. Sometimes we have code, sometimes we have cases, but in a lot of areas, we only have a textual description, which is then often manually elaborated and so on. But why not start from the original source? Of course, the original source will contain lots of things which are not interesting. So we somehow have to select which are the most interesting parts to build the decision model. Not everything will be automated or will go automatic. So there's some manual intervention. And then through some hocus pocus, the NLP, natural language processing pipeline, we try to build a DMN model in terms of dependencies and rules, and then feed it into some DMN tool. That's what we try to do. And of course, you will understand, and I admit that this is almost an impossible problem. You can do it, but will you do this for 100%? Of course not. Language is too complex, but doing a little is better than nothing. And that is the idea here. So we have text. In this case, medical guidelines for obesity, which we took from some website, which is used in some of the books. And a few sentences: the health risk level of a patient should be assessed from the obesity level, and so on and so on. This is actually a declarative sentence. It's not a rule in the sense that it will go into a decision table. It's a declarative sentence that tells us more or less what are dependencies. One decision might depend on another decision, might depend on an information item, and so on. So these will go into DRDs. And then we have sentences which are much more if-then sentences and all types of variations, conditional sentences. These will finally end up in logic. In this small example, they are easily formulated. Most legal specifications are way more complex, with many exceptions and so on. There are, for instance, there is legal rule ML to try to figure out the complexities of legal text. But here, in this case, and I think in a lot of cases, we can assume that the text is not that difficult. If it's a lot about premiums and conditions and small exceptions, then it's rules, 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 rules. So these are declarative sentences and conditional sentences of the form, for instance, something determines something else, or something is determined by something else, an active or a passive form of a declarative dependency. And a rule, if or if not, unless the season is summer, do not plan a barbecue. So do a result, an action, an outcome, if or if not something else is true. That's a conditional dependency, a conditional sentence. So there are some typical patterns, active, passive patterns. And now what we try to do in this small presentation here is try to select a text, a piece of a text, then look for these dependencies in a number of steps and come up with dependencies, and these dependencies form the basis of the DRD. The steps come in, there are 6 steps, and they come in 2 major steps. The analysis of the semantics and the analysis of syntax. Let me quickly go through the steps, but I think you can imagine what is going on here. We start from a sentence. For instance, from the obesity level, there are a lot of useless words, so the first step is to clean up. That's some pre-processing. Second step, try to figure out if some things are the same. The obesity level and the level of obesity is the co-reference. And with modern NLP tools, you can figure out that this co-reference actually means the same thing. So that's the second step, co-reference resolution. We only use standard, advanced, but standard tools for natural language processing. Then the pronouns, his obesity level is translated into the patient's obesity level and the patient's risk level. Resolution of the anaphora. Fourth step is recognizing the concepts. Health risk level is actually one concept. Obesity level is one concept. So the result is this concept should be assessed from this concept and this concept and this concept. Next step, the verbs. We identify the root action verb should be assessed from, and should be assessed from is some form of dependency. So we extract this dependency and say the health risk level depends on the obesity level. And that's what we need for a DRD. So what we extract from this text is, using some action verbs and some base concepts, we can figure out which are derived concepts. The obesity level, it's the other way around. The health risk level depends on the obesity level, and the health risk level depends on the waist circumference and depends on the sex. That's what this sentence actually was saying. So now we have a list of dependencies, dependency tuples. Is this perfect? Of course not. Text is way too complicated to do this perfect. But even for a reasonable text, at least you can do this automatically. You have a sensible result, and then with human intervention, you can adjust and you can try to understand what's going on. These are dependencies. Now we try to put the dependencies together using domain-independent heuristics. If a decision uses a data item, the decision has a result, BMI, and another decision uses this BMI, The concept is the same. If B uses A and C uses B, then the three are related. The decision C uses decision B uses data item A. Now we almost have our DRD. If you combine all the dependencies, decisions depend on data items, decisions depend on other decisions. We don't have knowledge sources yet, but we could take the sentence from the text and put it in a knowledge source. For the moment, we only do decisions, intermediate decisions, which is already a lot because it gives you the structure of the decision. The inputs and the requirements, the information requirements are identified now. And then we transform it in some XML. And if it's a standard XML, you can input it in a DML tool. For instance, what we did here is put it in Camunda, and the result is this. Almost fully automatic. Of course, you have to select the sentences a little, or the pieces of text that could be interesting, because text will contain a lot of junk also. But if you select interactively the correct pieces of the text, you will get this DRD, which says that the health risk level depends on the obesity level, depends on two information items, obesity level depends on BMI value, and so on. So we almost formed semi-automatically a DRD using these verbs. So text to DRDs. With a number of verbs, a list of verbs depends on, requires, defines. We could extend the list of verbs. By the way, we are building decisions. When building or when making this example, or when looking at this example, this was another example, prepayment is not required for loyal customers and so on. Actually, I started from a process. And when looking at the process, there was not even the concept of prepayment, because the process was something like you first have to check the order amount and then see if it's a long-time customer, and then check the average sales. And then in some cases, you send an invoice and you accept payment. And in other cases, you do this in parallel. And by just looking at the process, and that's of course why we are here in DecisionCAMP, we could see that it has nothing to do with the text processing. We could see that this whole process thing was actually about one decision. We have two versions of the process, one where the customer has to pay in advance and one where the customer can pay later. So the process to me, and that was not in the process model, it might have been in a text, is that you have two variations of the process. One is, they have one decision. You first check, do you need advance payment, yes or no? And depending on that, we have two different processes, which I modeled as sub-processes here. And the decision advance payment, of course, has a number of criteria and has a structure. And there you can see that the concept of a good or a long-time customer, a loyal customer, will come in. That's just a side, but it again shows how you should start from the decision and not just from the process. Second part, the decision logic, which of course is very easy if your sentences are very standard. If this and this is true, then that is true. Yeah, okay, that is very easy, but in reality, it's not that easy, of course. You can have some synonyms like if and when and unless and if not. There is a taxonomy of verbs indeed, see in the questions, but we just started from a very limited list to see if this concept could work. And now we are extending with the rules and more verbs and more patterns and so on. So this is a simple sentence, a simple rule. And for the moment, we only do a few simple rules, an if-then rule, very explicitly, when you see in the text if-then, or a synonym, unless, do this, do that, or that is the result, or an implicit if-then. Any customer with high sales is a loyal customer. That's also some kind of rule. These are the only three simple patterns we look for. I know that in reality, rules will be much more complex, will contain ands and ors and unless and so on, but for the moment, this works well. Oops. So for this small text, where's my text? My text is gone. Okay. For this small text, you can identify a few rules, as you can imagine. Here is the example. We have few dependencies, we have decision logic, we identify a few rules, and of course these rules will go in tables. The tables will be attached to the decisions in the BKMs or in the decisions. And for this example, which is small but not unrealistic, you can build a DRD, you can build the logic, even the full logic for this small example, and you almost have a working decision model. So now I come back to my total picture. In DMN, we do the modeling, we do the validation, we do the execution. We could spend a little more effort on where does the model come from, the mining or the manual modeling. Well, we've done that for a long time. And now we could spend a little more time on, maybe we could do this automatically from language, because there is so much text. Some text is very complex, but there's also so much simple text. That's why I call it decision making from A to Z, from text to the final application. Final application, oops, sorry. Oh, by the way, this is the full model in Camunda with the elements put in a table. Now, of course, if all the rules are very nicely formulated in the text, which they never are, then you have a nice, unique table with complete and consistent rules. If not, you need some kind of intermediate step to make the rules unique and to format and not format, simplify and form the table well and so on. But for this example, you can almost perfectly derive the entire decision model and tables and good tables from the text, which is already something. Looking at the full picture now, if you start from a text, I call it the knowledge source here. And of course, with the help of a modeler, I see a question by Dennis, indeed, some parts are not automated. Selecting the text or selecting the relevant pieces of the text is still something that has to be done together with the modeler. From then on, the process runs more or less automatic. Of course, there are concepts you have to check this. It's not fully automatic. You have to check the concepts and the decisions to see if this makes sense, of course, because if only the text would be perfect, then you can do it fully automatic, but it never is. So basically, from the text, we derive a decision model. Once you have a decision model, you can execute it. This is just one example, but no matter how you execute it using REST APIs and so on, the big issue is where do you start from? And once you have your decision model, we can find ways to execute it. That's what I just wanted to illustrate. So if we started from the text, we can build some kind of end-user app about the BMI example. So basically what we can do here is we start from a text. If we are very lucky, we can automatically derive the decision model. And then if we have good tools, and we have good tools, we can automatically build an application without almost no programming, no effort, no modeling. Of course, we need some manual intervention, but it's semi-automatic. And then you can even go further. And that's the subject of the other talk. Not immediately now, but it too talks about the other part of K11, dealing with the reasoning, because decision-making is not just if you have all the inputs, take a decision. Decision-making is also, given that I have some inputs, what do I already know? Or given that I have some constraints, what do I know? How do I optimize? How do I simulate? That's not the topic of this talk, but that's part of the cooperation we have within the same university. And that makes it end-to-end from the basic text to the model, to the basic execution, and to more advanced reasoning to build intelligent applications. That's the purpose. Will this work in a few months? Of course not. Is it useful? Yes, because there are all these texts. which are not that complicated and which are ready for some basic automation. Are there any caveats? Are there any challenges? Of course. Text is very complex, contains ambiguities, is never complete. I've never seen a legal text which is complete unless you build it yourself. We've done it once from a decision table. You first build the table, make sure it's perfect, and then generate the text, and then you have a law which is okay. So there are some challenges. There are challenges in extraction. We don't deal yet with hit policies and all these things because texts can be very complex. And if you want to reach a good decision table and a good decision model, you have to deal with rules and policies. But there is huge potential. Automation of text, and then using it in chatbots, personal assistants, explainable text. It's not only explainable AI, but explainable text. What does this text mean? These are the criteria, that's where it depends from. These are the data, what do I know, and so on. And maybe later the opposite way, generated text from decision models. So it's, let's say, an academic challenge. We have a prototype. This seems to work. And what we will do now is test this on first small samples and then larger samples, and then see how well it performs on real text and real data. Where is this useful? It adds explainability, very important. There are a lot of systems that depend on these textual guidelines, policies, and regulations. There are so many of them, so we should really do something about it. There's no time to translate them all manually and then do the manual validation and verification and so on. We should automate explanation and small decision making. And so we can use the same document, if this would work perfectly, which it will never be, but then we could use the same document both for reading, publishing, interpretation, execution, which is a very big advantage. There are no more translations. And of course, that is the idea. All right, I added some references for your use later. Let me have a look at the chat here. Jan had another question.
I can help you out with that too, Jan. Thanks for the presentation. It's just, it looks like Lloyd and Jan Purchase were having a little back and forth about the list of verbs. Is this an identified flat list, or is there a taxonomy of verbs? And then if you look at the sort of the replies to that, it's Jan said you could use tagging to identify verbs and WordNet, and then Lloyd says that you can use that, but identification of the verbs is very cool, as he says, but cataloging against a reserved class implies a standard structure of sorts, which he thinks is cooler. Do you have comments on that?
I would say my only short comment now is whatever we do is better than nothing. Of course, it's not a complete list of verbs, it's not a complete taxonomy. We wouldn't lose all our time in coming up with the perfect taxonomy. If you have a simple text, you can derive already a lot from a simple text using 10 words, which are commonly used in practice. This depends on, this is calculated from, this influences that. So let's try to do the simple things first and then go to the more complicated things. That would be my answer.
Okay. So Matteo has a question. He says he finds this a super interesting use of natural language processing to determine a DM and DRG. And are you planning to experiment, do some research in domains besides medical? Because he's sort of links back to some of what was being discussed in the Ask a Practitioner panel yesterday.
The medical example was just, well, actually an exception, because most of our examples will be in small legal things and eligibility rules and requirements and financial insurance stuff. But it's sometimes not easy to find a good small example, because once you go to the finance and insurance world, as Brian was telling, there are so many rules and regulations, and we needed a simple example or a few simple examples. We tested on a few examples which are basically simple, and now that is the work for the summer for the PhD student. We are looking for good examples, not too simple, but also not too complex.
Right. And I think he has a really good point here, as we were talking yesterday during the panel about how it's sometimes difficult to explain what a DRG is to an analyst or have them sort of strike out and build one on their own. Possibly an interactive tool where they can write things in plain English and then, or plain language,
Yeah, maybe
any language, and then the DRD is sort of built dynamically.
we didn't even think about this from the start, but this would mean that you could do, for instance, voice recognition, say a few sentences, and it might be able to build some kind of DRD.
Mm-hmm. I'm seeing some similar things that have happened on process modeling as well, where it's the idea is that you can have people, use natural language and then build the model from it. I think the whole idea of going from natural language to a model, whether it's a decision model or a process model, is really kind of a cool piece of research.
I'm not sure we can do it in real time, as Ellen is suggesting, but anyway.
Right. You're going to need a bigger computer. Yeah.
I see my co-author responded in the chat that we don't use the taxonomy yet because we want to keep it domain independent.
Right, right.
Which is true.
Denis had a question in here. He said it's not clear what's automated and what's manual in your suggested solution. And can you clarify that?
Yeah, I tried to add to that. Of course, the selection of the text is something which is almost manual. You might give the impression that you have this nice piece of text, but you have to look for a good text, of course, because there is so much junk in all texts. But once you have a piece of text, you can do a lot of this automatically. Of course, after every step, you look at what did I see as concept? Does it match my expectations? You will improve it if you do it semi-automatic, but it could be done almost fully automatic.
Mm-hmm. And Ulrich asks a question. It's right at the bottom of the Slack channel right now. He says, "Is it really possible to develop decision logic without semantic understanding
No.
because of the automatic text analysis?"
No. Good question. I don't believe in the perfect conversion from text to tables and so on. If you only look at how difficult it is to do this manually, I spent so many years developing good methods and models, but that doesn't mean it's not useful if you have a semi-automatic way to do 70% or 80%, then you can spend your time on, let's check if this is really correct and so on. I don't think it will be done fully automatic, but how do they say this? Whatever works already is fine.
Right. So because if you have subject matter experts who are putting information into the tool to help with the semantic understanding, then somebody who's at the, just sort of inputting data into it or inputting language into it, maybe like requires a little bit less knowledge.
It's like we use text translation, as Jacob suggests. We all use Google Translate and then we read it through, but at least we don't have to type all the text.
Right,
so it helps.
Right.
Yeah.
So Denis is asking a follow-up question. He says, don't you need to assume that the text provides complete logic and is consistent? And their experience in healthcare is that most text is inconsistent and incomplete. And what's your strategy for dealing with that?
I know. Completeness is not so much a problem because if you derive the rules from the text, you put them in a table and you use the correct hit indicator, you can immediately see where the incompleteness is. A good table modeling tool will signal you this and this is missing, this is inconsistent. Of course, it would be even better if you can do it earlier, but there are ways to do that. But also there, the answer is the same. Whatever we do, no matter how simple it is, it's always better than doing nothing and having to do everything manually.
Right. Okay, good. Just one last question. I know we're right at the time. As Alan Fish says, maybe the big missing component is pragmatics rather than semantics. How do you know what decisions are required from a piece of text which might provide information for them?
Yeah, that's probably where most of the human help will have to come from. Depending on the example, of course. If you have a text about BMI and you know that this is a text about BMI, that's no problem. But if you have any normal legal text, you don't even have an idea what they are talking about or what the decision is. I agree with Alan. It's a big missing issue, but we'll see.
Okay, great. Well, thank you very much. It was a great presentation, and there's still, some conversation going on over in the Slack channel, and you can definitely continue the conversation over there.
Okay, thank you, guys. Bye.